Hello, welcome again to lesson 6 of sequence block 1. I'll share my screen. So, in your previous lesson, you learned how to continue numerical linear sequences. So, recall or remember that a linear sequence would have a constant difference. Okay, so that means the numbers by which the terms of the sequence is changing from one term to the other will remain the same. So in today's lesson, we'll see a different sequence. Of course, you should know nonlinear sequence would have the numbers being different. Okay, but before we start, I would like you to do this retrieval practice. I'll give you 2 minutes should be enough for you to do this. Okay. Okay, let's check our answer. So for question 1, don't forget the very first skill you learned from lesson 1. That is to be able to draw the next term in the sequence. You should be able to describe the sequence first. In fact, it helps to write the numbers out. So this is 1, this is 2. You can see that is 4. So you notice that every time the number by which we increase the sequence is increasing by 1. Okay, and then you can describe the sequence in words. So we done work on this from even the very first lesson on sequence. Okay, so retrieval practice is to help you recall what you learned before and then link it to your new learning. So here are the answers. Okay, so the next one would be um would be this sequence here. All right, and then the number of squares added each time increases by 1. It's a non-linear sequence, okay, because the numbers are changing. It doesn't remain constant, the numbers by which you are increasing each terms of the sequence. Okay, let's do some new learning. If I give you this sequence, all right, so here is a non-linear sequence. It is found by doubling the previous term. Okay, of course it's going to be a non-linear sequence because the amount will be changing. Yeah, if we wanted to check how much we're adding each time to generate the sequence, it would be, changing. All right. So, but in this case, we're doubling each previous term to get the new terms of the sequence. Now, look at this one. This is a different nonlinear sequence. It is found by increasing the number added to the previous term by 1 each time. So we start with 3. We add 3. Okay. We're going to add 4. Next, we add 5. All right. So again, this is a nonlinear sequence. Now I want you to have a think. Write two different nonlinear sequences where the first term is 10 and the second term is 30. I want you to have a think. What would you get? I'll give you a hint. Multiply the previous term by 3. Okay. Okay. So if we do that, we'll get 90, 270, and then 810. So each time we're multiplying the previous term by 3. Okay. What about this one? Add 5 to the previous term, then multiply by 2. That is one way to look at the sequence. Okay. We could also generate another sequence by saying, okay, I'm going to multiply the previous term by 2 and then add 10. We'll get the same thing. Yeah. So it's really important to know that for nonlinear sequences, there are different rules. So take note of that word. We'll come across, you will come to it at some point in, in our future lessons. The rules can change, but we can, generate the same sequence, nonlinear sequence. Okay. So these are the, types of nonlinear sequences you're going to be dealing with. So far, what we have learned is that you can generate a nonlinear sequence by varying the rules by which you get from one term of the sequence to the next term of the sequence. So remember, the title of our lesson is to continue a nonlinear sequence. Yeah. Numerical nonlinear sequence. Numerical means numbers. We're dealing with numbers today, but it happens that the sequences are going to be nonlinear. Okay, I want you to have a go at questions 1 to 4. This should take you 6 minutes. Okay, we have 2 minutes left, guys. Okay, let's check our answers. So for these questions, you can see that they are non-linear sequences. Okay, and you're being told for this one, you can clearly see for the first one, you can clearly see that we're doubling each time. You've been told what to do, and then for the other sequence, for the other questions, you're given the sequence. You require to find out what's really going on, or what rule, or how you would describe how you get from one term of the sequence to the next one. Okay, so with this one, it works with really observing the numbers and then looking at how it is being generated. So, for example, for 2a, you can see that we're halving every time. Yeah. And then I'll go to 2D, which would have looked, 2E, which would have looked a bit challenging, but it really isn't. You can see we're multiplying the numerator by 2. We're doubling the numerator every time. Sorry, we're doubling the numerator every time. Okay. And then for 3, you're required to, you know, check what's going on with the sequence. You can see for this one, we're multiplying by 3. Okay, so you really need to, if you good with your times tables, these should not be a challenge. So my advice is, if you found, just looking at the numbers scary, oh, how do I figure this out? Just know that you need to be practicing your times table. Okay, it's very, very, very important. All right, that builds confidence with numbers. All right, or for some other students, those who have done Vedic mathematics, you should be really good with some mental maths techniques. Okay. But, in this case, the very basics is you should be good with your times table. Okay. Here are the answers. You can mark your work now. Okay. Let's move on. So, the first term of a sequence is 14. All right. So, let's build on what we know so far. Now, if we're told that the next term is found by multiplying the previous term by 3 and subtracting 10, okay, of course, and then we're told to find the first 5 terms of the sequence. This is where our maths techniques come in. So you should be able to do your multiplication techniques, which you learned in primary school. So you do 14, okay, by times 3, and then you subtract 10. You're going to get this, okay. So you do 14 times 3, and then you subtract 10. And then that's how you generate the sequence. Yeah. Um, so on and so forth. Okay, so those are the rules you're going to get given. So you're doing, if you then ask, okay, predict the last digit of the next term without calculation. These are the sort of questions we get. So when you're generating each term of the sequence by following the rule that was given to you, okay, so the rule that was given to us, you can see I've introduced the new word rule is, which is another way of describing the sequence. The way the sequence is described, which is also the rule, is you generate the next term by multiplying the previous term by 3. And then the first term that was given to you was 14. You multiply by 3 and you subtract 10. Now, when you do this, you start to notice in some sequences, you start to notice patterns. So you can see here, the last digit of the first term is 4. The last digit of the second term is 2. You see, next one, 6, 8, and it starts all over again. So you clearly see that the next number that you will generate will have the last digit being 2, because that's the pattern. Okay, so you could have answered that question really simply to say, okay, it's going to be 2. Okay, all right, you can see that. All right, have a go at the rest of the questions. First, I would like you to answer questions 5 and 6. I will give you 3 minutes. You should be able to do this in 3 minutes. Okay. Okay, we have 1 minute left. So you can work at your own pace, right? If you're not able to finish these tasks in the time, you can pause the video, work on it before you check your answers and mark them. So don't worry that if your pace is a bit slower. Okay, let's check our answers. So for the first one, you can clearly see that we're told we're given the rule to produce the sequence. We're told a sequence starts with the number 23. The next term is found by multiplying the previous term by 2 and then adding 7. So you just multiply to get the next one from 23. You multiply 23 by 2 and then you add 7. Okay, and then you need to generate 6 terms, okay, of that. The next one, we ask to find the next term in the sequence. You multiply the previous term by 3 and subtract 2. So if we were to do that quickly, I'll just do the first and the second one. If we were to do that quickly, so the first term is 1. We need to multiply the previous term by 3. So 3 times 1 is 3. And then 3 minus 2. So subtract means 3 minus 2 will be 1. Okay, this one, you can see the previous term here now is 1. So 3 times 1 is 3. And then if we subtract 2 again, is 1. Okay, you can see that that is what we're going to be getting. So 1. Because each time we multiply the previous term by 3 and subtract 2, we're going to get 1. Okay, if we move on to this one, you'll see that you get 3 times 2 is 6. 6 minus 2 is 4. Okay, then the previous term is 4. 3 times 4 is 12. 12 minus 2 is 10. Okay, so if we keep doing that, you're going to notice this. All right, now what I'm going to be discussing is what the little girl said. He said, if you compare all of the second terms, they form a linear sequence with a constant difference of 3. So they're talking about this. So if you were to compare all of them, these, you would see that they form a linear sequence with a constant difference of 3. Okay, let's check the answers and then you'll see that is exactly the case and you will explain why. Okay, so you can see, yeah, so this is what we get, all right, when we generate our sequence, and you can see that that is the case. So between 1 and 4 is 3, between 4 and 7 is 3, between 7 and 10 is 3. That shouldn't surprise you because what we're having is we're moving one step down every time, but don't forget we're multiplying by 3. Okay, we're multiplying by 3. So it's just like increasing by 3 every time as you go down, this block of sequence. Okay, mark your work and we'll move on to the next task, to the next learning. Sorry about that. Okay, so I'm sure you've marked your work. And that brings us to the end of our lesson. Okay, so what have we learned today? So far, we have learned that you can continue non-linear sequences by following the rule. Okay, you're going to, first you could get given a rule which is really obvious. For example, the last one we did was, you were given a sequence which starts with 23. You were told to multiply by 2 and then add 7. Sometimes you will get given the sequence and you need to observe. So this is where you use your number sense. So you need to observe the number. What is the number doing? What's the property of the number? Okay, and then you find out the rule. Okay, how the number is being generated from one to the next. Okay, sometimes the rule to describe it, to get the rule will be really easy. Maybe you're just using one maths operation. But sometimes remember that to generate the rule, it could be using more than one maths operation. For example, remember in our very first example we looked at, we were adding 5 You can be adding 5 and then multiply by 10. You can have that example, or you can add 10 and then double. So you know that in describing some nonlinear sequences, you could be using more than one maths operation. It's not as simple as, oh, I'm doubling, or I'm subtracting, or I'm adding particular numbers. So it's really good you apply your number sense in this case. Okay, that brings us to the end of our lesson. Until next time, take care and bye now.